So today we will start the part B in your lecture handout in endocrine system. So thyroid gland. Thyroid gland is located in the neck. Thyroid gland has two lobes and those lobes are connected by a narrow region known as isthmus. When we look at the thyroid slide under the microscope, we see follicles. Follicles are round structures. They are lined by cuboidal epithelium. Follicles produce hormone thyroglobulin. This hormone is in the form of colloid and it fills the lumen, means space, in the follicles. Thyroglobulin combines with iodine and makes thyroid hormone. Parafollicular cells, as the name says, para means perimeter around. So parafollicular cells are also known as C cells. They are not inside the follicle, they are outside of the follicle and they produce calcitonin. So we see here thyroid gland in the neck area just below this thyroid cartilage, and this is the isthmus, narrow region connects the two lobes. This is the slide under the microscope. We see these are the thyroid follicles. In the center is thyroglobulin and it combines with iodine to form thyroid hormone. So thyroid hormone has two forms, T4 and T3. T4 is known as thyroxine. It has 4 iodine atoms. T3 has 3 iodine atoms. Thyroid hormone actually affect every cell in the body. So about every cell in the body is the target cell for the growth for the thyroid hormone, same as growth hormone. Thyroid hormone is considered the major metabolic hormone. Why? Because it increases our metabolic rate. Means how the food is broken down to provide us energy, how the heat is produced by the food we eat. All those reactions are in metabolism. Thyroid hormone regulates tissue growth and development. So thyroid hormone works with the growth hormone. Thyroid hormone is important for normal skeletal development, nervous system development, and especially for reproductive organ development. Thyroid hormones also maintains blood pressure. People who have low thyroid, they have a low blood pressure. So this is the way they are showing. This is the thyroid hormone in the form of colloid, and then how, like, if we start from here, thyroglobulin is synthesized, iodine is added. You don't need to know all this detail actually. T4 and T3, they are transported by a carrier protein binding globulin. It's a carrier protein. T4 and T3 then bind to their target cell on their receptors. Now this is important, which is more active. T3 is 10 times more active than T4. And that is the reason peripheral tissues in our body convert T4 to T3. So know which one is more active, T3 or T4. Increased thyroid hormone levels provide negative feedback inhibition on release of thyroid stimulating hormone. So level of thyroid hormone is maintained by negative feedback. How? First of all, hypothalamus produces thyroid releasing hormone in the anterior pituitary, and then anterior pituitary releases thyroid stimulating hormone. So if we see here, hypothalamus is releasing thyroid releasing hormone in the anterior pituitary. Anterior pituitary is releasing thyroid stimulating hormone, which causes thyroid gland to produce thyroid hormone. And thyroid hormone binds to the target cell. As the level of thyroid hormone increases in the blood, it will inhibit the hypothalamus, it will inhibit the anterior pituitary, and that is negative feedback. Homeostatic imbalance of thyroid hormone. So this is important. Know what is hyposecretion, what is hypersecretion. Hyposecretion, in adults, it will cause mixed edema, means the person will feel tired all the time. They will gain the weight even if they are not eating much actually. They will have a dry skin. They will feeling cold most of the time. They will have low blood pressure, low metabolism. Goiter, if due to lack of iodine. If their diet lacks iodine, you will see a outer growth in the neck area, overgrowth in the neck area, because the thyroid gland gets larger. So that causes goiter due to iodine deficiency. If the thyroid hormone is hyposecreted in infants, then it will cause cretinism in the infant, means the infants will have later mental development. Hypersecretion, if too much thyroid hormone is released, it will cause Graves' disease. So what will happen? The person will have protruding eyeball. Person will be feeling hot, will be sweating. Person will be very irritating. Their metabolic rate will be high. Blood pressure will be high actually. They will have hypertension. So this is the hypothyroidism, and this is hyper C X ophthalmos, eyes are bulging. Calcitonin. Calcitonin is a hormone which is released by parafollicular cells in thyroid. They say no known physiological role, but calcitonin is antagonist to parathyroid hormone, and calcitonin actually decreases the level of calcium in the bone, because calcitonin deposits calcium in the bones. At higher than normal level, calcitonin inhibits osteoclast activity and it stimulates calcium absorption by the bones. Parathyroid glands. 4 to 8 tiny glands located on the posterior surface of the thyroid gland. These parathyroid glands have oxyphil cells and chief cells. Those cells release parathyroid hormone. Parathyroid hormone is important to maintain the level of calcium in the blood. So see, these are the parathyroid gland. So there are 2 pairs and they are located on the posterior surface of the parathyroid gland. Now see, these are the oxyphil cells and these are the parathyroid cells. Parathyroid cells secrete parathyroid hormone. parathyroid hormone. Parathyroid hormone stimulate osteoclast activity. So the bones are like kind of dissolved. They kind of not fracture, but they kind of broken. So they release calcium into the blood. So this is important to know what parathyroid hormone does. It increases osteoclast activity. So the calcium will be taken out from the bone and released into the blood. And that calcium will go into the intestinal mucosa. And so if too much parathyroid hormone is released, bones will get weaker. The level of parathyroid hormone is also maintained by negative feedback. If level of calcium goes up in the blood, it will inhibit parathyroid hormone release. So like see, this is hypocalcemia, low blood calcium level. So parathyroid gland will release parathyroid hormone, it will increase osteoclast activity, it will increase calcium reabsorption, but in kidneys activation of vitamin D. So that one happens when the level of calcium increases, then the level of calcium will increase and come back to normal. Hyperparathyroidism. Hyperparathyroidism, like suppose there is a tumor, then it causes hyperparathyroidism. Bones will get weaker and weaker, they will deform, the level of calcium will be high in the blood, so our nervous system will be depressed and there is an increased risk of kidney stone. Hypoparathyroidism, it is due to the trauma or removal of the thyroid gland and it will cause tetany in the muscles. It can cause also respiratory paralysis. If very severe, it can cause even death. Adrenal glands. There are 2 adrenal glands and each is sitting at the top of the kidney. The kidney has this adrenal gland has a central region known as adrenal medulla. Adrenal medulla is the part of sympathetic nervous system and it releases 2 hormones, epinephrine and norepinephrine. Together they are known as catecholamines. The outer region of the adrenal gland is known as adrenal cortex. It has 3 layers of the glandular tissue and they release the hormone known as corticosteroids. So adrenal cortex has 3 regions, like it is divided into 3 parts. Subdivisions. Zona glomerulosa produce mineral corticoids. Zona fasciculata produce glucocorticoids. And zona reticularis, the innermost part, subdivision of adrenal cortex, produces gonadocorticoids. So see here. Zona glomerulosa, zona fasciculata, zona reticularis, and then here is the adrenal medulla. Adrenal medulla produces epinephrine and norepinephrine. Here is the adrenal gland sitting on the top of the kidney, central region medulla, outer region cortex. Mineral corticoids. As the name says, mineral, they regulate electrolyte, means they regulate sodium and potassium level in the extracellular fluid. Sodium is important because it affects extracellular fluid volume and it affects blood volume, blood pressure,